This is the homework help for section 6-4, factoring and solving polynomial equations. We're going to go over a few problems from your homework here, and let's start with number 37. Number 37, we're asked to factor this expression. Right away, you should notice this expression is a cubic, so we're not factoring quadratics like we did in last chapter, but we're factoring a cubic. And right now, all we know how to do is factor by grouping and special forms sum and difference of two cubes. So we have to look, is this one of our special forms? Is it a sum or difference of two cubes? Well, we're adding, so we know it's a sum. So we have to check, are these two numbers, or these two terms, perfect cubes? Well, we can look at 27 and see that that is just 3 cubed, because 3 times 3 times 3 is 27. And if we look at 1000x cubed, well, that's the same as just taking 10x and cubing that quantity. So this is in fact a sum of two cubes, and our a in this case, if we remember our form here, let's go ahead and write it down. If we have a cubed plus b cubed, it will factor into the quantity a plus b, and then we multiply by a squared minus ab plus b squared. So we have to ask ourselves, what's a? Well, a in this case is 10x. So wherever we see a, we just put in a 10x. And b is 3. Now, why is a 10x? Why is b 3? Well, a is 10x because we cube 10x to get 1000x cubed. And we cube 3 to get 27. So you can write a note to yourself, a is 10x. b is just 3. So let's go ahead and plug that in here. So this becomes 10x plus 3, and then 10x squared becomes 100x squared minus a times b, so we multiply the 10x and the 3x to get 30x plus b squared, which is just 9. And in this case, all we wanted to do is factor, so we have factored our cubic. Factors into this binomial, this trinomial, and notice that this trinomial cannot be factored any further. And if we were to find solutions, that would actually give us two imaginary solutions. But right now we're just factoring, so that's all we want to do. Let's take a look at factoring one that involves grouping. So we look at this cubic. Once again, this is a cubic, but it's not a sum or difference of two cubes. So we look at how can we group these together and factor from those groupings. So we take out a greatest common factor. Well, we look at 2 and 5. There's no number that can go into 2 and 5 evenly other than 1. So that doesn't help us. But we have x cubed and x squared, so we can factor out an x squared. And if we pull out an x squared, what are we left from here? Well, that's 2x. And if we pull out an x squared, what are we left with? That's 5. So x squared times 2x, x squared times a negative 5, just gives us the 2x cubed minus 5x squared that we had before. And we look at 18x minus 45. Well, there's only an x term in the 18x. There's no x here, so we can't pull out an x. But we can pull out a greatest common factor of 9. And once again, we're left with 2x minus 5 on the inside. Because 9 times 2 is 18, 9 times 5 is 45. And notice, these are the same. And if they're not the same, we can't factor by grouping. So those have to be the same. If they're not, one of two things. Either you mess something up, or two, it can't be factored by grouping. All right, so how can we simplify this? Well, if this is 2x minus 5 there, 2x minus 5 there, we can rewrite this as x squared plus 9, that quantity, because we have an x squared 2x minus 5, and we have a 9 2x minus 5. It's the same as multiplying the sum of x squared plus 9 times that 2x minus 5. And once again, if we were to FOIL this, we would wind back up with that cubic that we started with. In this problem, we only wanted a factor, so we are done with that factored form right there. Now with this last problem, I want to take a look at one that we need to solve. Okay, so in solving this, we want to factor the left side, and then we can use the zero product rule and find all of our solutions here. Well, first thing we should always do when we're trying to solve is see if we can take out a greatest common factor, especially a number that we can divide and simplify our equations. In this case, we see that that's 2, 26, 72. What number do all of them have in common? Well, we can divide everything by 2 to make this a little simpler. So we get x to the 4th minus 22 divided by, or 26 divided by 2, excuse me, is 13x squared. And then 72 divided by 2 is 36. And that equals 0. Alright, so now we look at, wait a minute, we've got an x to the 4th and x squared. There's no x cubed term, and there's no x term. So this is a special case in which we can use our quadratic rules and still factor. And it factors into x squared and x squared, two binomials that will have x squared in the terms. So we have to think, alright, a factor pair of 36 that adds up to a negative 13. So I want you to take a second and think about what's a factor pair of positive 36 that adds up to negative 13. Okay, hopefully you had a chance to think about that for a second. And if we look at this, well, 36, I need two numbers that are a factor of 36 that will add up to a negative 13. Well, those two numbers are negative 4 and negative 9. Alright, well, you might think, okay, great. Well, we can set x squared minus 4 equals 0 and x squared minus 9 equals 0. Well, you could, and in which that will work, and you can solve by taking the square roots, but you have to make sure you remember the plus or minus. Or we can continue to factor these. Alright, this can be factored even further into x minus 2, x plus 2, because this is a difference of two squares. This is taking us back to chapter 5 when we had the difference of two squares. X squared is a perfect square, 4 is a perfect square. So difference of two squares, x minus 2, x plus 2. And then we can factor this into x minus 3, x plus 3 by the same rationale. Alright, well, if we have these four pieces, sorry about that. If we have these four pieces that are all multiplied together to equal 0, that can only happen when x minus 2 equals 0, when x plus 2 equals 0, when x minus 3 equals 0, or when x plus 3 equals 0. So what are our solutions? Well, from this one we yield x equals 2, x equals negative 2, x equals 3, and x equals negative 3. And you can write x as a solution set of negative 2, 2, negative 3, 3, however you want to write it. That is your set of solutions. Hopefully that gives you a little bit of help with Chapter 6, Section 4 homework. If you have any more questions, please feel free to bring them to class. Good luck.